arithmetic sequences defined recursively. So our objective for this lesson, is I can use arithmetic sequences defined recursively. We're going to talk about what this recursively means to solve real-world problems. Okay, so first of all, this word arithmetic, sometimes it's pronounced arithmetic, an arithmetic sequence or arithmetic sequence. We're going to talk about what an arithmetic sequence is, but first, just a sequence in general. A sequence is a list of numbers in a specific order. So, important word there is a specific order. The order they're in matters. So, you have the first number, second number. So, we call each number in this sequence a term. Case for example, if I had a sequence of counting by 5, 10, 15, 20, ... Each of these numbers we call a term in the sequence. And the sequence is this list of numbers, but they're in a specific order. They have to be in this order. Okay, and so like this one we would call the first term, the second term, so forth and so on. Okay. All right. So here we have for task 1, the table displays part of a sequence that models the total cost of piano lessons based on the number of hours of piano lessons. So if you notice over here, the first piano lessons, it's $50 for the first hour and $75 for each additional hour. So the position in the sequence gives the hours, I'm reading right here, the position in the sequence gives the hours of piano lessons, and the terms of the sequence gives the corresponding total cost. So for sequences, we talk about the position. What we mean is where is it in the sequence? For example, up here in my 5, 10, 15, this 15 is the third, this 15 is the third term. That's its position, where it's at. It's the third term. It's the third in the list. Okay, so we number our terms based on their position. So my position here is the number of hours. So here, this position here is the number of hours. So I'm going to go ahead and list this. This is the number of hours of lessons. And the term, this is the cost. This is the money, the cost. Okay. So 1 hour would be $50. 2 hours would be $125 because we're adding. From over here, we're adding $75 for each additional hour. $3 would be another $75. So we want to complete this table for integer values of n from 1 through 10. So, okay, integer values of n. So here's my n. We have it for integer values of 1, 2, 3. So now we need to finish it. For 4, we want to go all the way up to 10. And what we mean by integer values is we're not doing no in-between numbers. Meaning we're not doing like no in-betweens, for example, like 1.5. Okay, we're just doing the integers where our notches would be on a number line. So 4, we would need to add 75 because it's 75 additional hours. So here we're adding 75 each time. So this would be 275. Okay, for 5, I'm going to show you a neat trick using your calculator. Oh, sorry. Okay. Sorry. No. Here we go. I want to just bring it in picture in picture. Okay, so what I can do is I can start with my first term, 50. And each time we add 75. So to get to my next term, there's my 125 right here. There's my 125. Now, instead of hitting 125 plus 75, I'm just going to hit plus 75. So what that does is this right here takes the ANS, says takes previous answer and adds 75. So that gives me the 200. If I just keep hitting enter, it's going to just keep taking that previous answer and adding 75. So my next one's 275. My one after that would be 350. So we'll go ahead and mark that down as 350 for the 5th term. We're just continuing the table. 6th term, enter again, 425. 7th term, enter again, 500. Enter 575 for 8. 9, we want to go up to 10. 650. 725. Okay. All right, so that was my calculator trick that I showed you. You just do the previous answer and keep hitting enter. Okay, so there we completed our table for integer values from 1 to 10. Okay, using the table, find the total cost for 5, 8, and 10 hours of piano lessons. Write your answer using function notation. So function notation, if you notice, this is f of n, where n is the position. So first, I'm going to identify these points up here. So we want the total cost for 5 hours would be here, 8 hours, and 10 hours. Okay, so to write that in function notation. So the fifth term, or the cost for 5 hours, I would write as f of 5. That's the cost of 5 hours is $350. So there it is in function notation, because this is my input, or my n, and this is my output, or my f of n. Okay, so I do the same thing. F of 8 equals 575, and f of 10 equals 725. Don't ask me why you would do 10 hours of piano lessons. Oh, maybe throughout a couple months or something. Okay. Next question, what is the domain? Again, the domain is the set of all inputs. And what does it represent? So my domain in this case is we're only dealing with integer values. You can't do half an hour of piano lessons according to this, apparently. We can only do integer values. So my domain would be the set of numbers starting with 1. I could do 1 hour, 2, 3, 4, 5, so forth and so on. So I go dot, 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 parentheses, showing it goes like that for forever. And what does it represent? It represents the number of hours of piano lessons. Number of hours of piano lessons. The input, again, the position, my input n, is the number of hours. We labeled it there. So now what is the range? Well, what are my possible outputs? Well, I don't know. Let's look at my outputs here. The smallest output I can get is 50. So my range starts at 50. But the next number I get is 125 and then 200. We want to do enough to establish the pattern. Dot, dot, dot. Continue like that for forever. What does it represent? It represents the cost of the piano lessons. It's the cost of the piano lessons. Okay, what does the ordered pair 7, 500 represent? So this is my input. This is my n, my input. Up in my table here, we decided my input was the number of hours. So this would mean that 7 would represent 7 hours of lessons. So then what does the 500 represent? The 500 is the output. Up here, we decided our output, our term f of n, is the cost. So 7 hours of lessons costs $500. Okay. How many hours of piano lessons can you get for $350? So again, this is the cost. This is the output. I want to know how many hours. I'm trying to figure out the number of hours, which I'm trying to figure out what is the input that gives me an output of 350. So we come up here and look. We want an output. So we're looking at these numbers of 350 right here. So that would give me the 5. So 5 hours. All right. So this is just talking about a sequence in general. Now, to talk about an arithmetic or arithmetic sequence, an arithmetic sequence is a special type of sequence, okay, in which consecutive terms, so one that come right after another, okay, one right after the other, have the same, sorry guys, I'm missing a word. Terms differ by the same number d, oh no, here we are, called the common difference. Okay. Basically, in your sequence, if it goes up or down by the same amount each time, it's an arithmetic sequence. So this one that we just did here, it went up. We notice here, we said it went up by 75 each time. Each time we went from one to the other, it went up by 75. That makes that an arithmetic sequence. So here we go ahead and denote it. That makes that the arithmetic sequence. Okay, so we go 50, 125, we go up by 75 each time. Now to talk about notation. Okay, so we already talked about it a little bit. So basically my first term, f of 1, in this case is 50. So f of 2 in this case is 125, so forth and so on. And we would say then that f of n is just any random term. Okay, so we've seen f of x before. For sequences, we tend to use n instead of x. Use n instead of x for sequences. It really doesn't matter. That's just our standard. We use an n instead of an x. So f of n is just basically meaning any random term. The one thing you may not have seen before is this f of n minus 1. Okay. F of n minus 1 is it's taking, so let's say if I was talking about the 10th term, f of n minus 1 would be 10 minus 1, which would be f of 9, which is the term directly in front of my 10th term. So f of n minus 1 is just a way of talking about a previous term. Okay, so f of n minus 1 is just talking about the term before the 10th term. Okay. So just so you're not that notation, it's, again, this is still this whole thing here. Sorry. The n minus 1. This n minus 1 is still the input. Even though it has a subtraction in there, that's still the input. It's just telling me that I'm inputting one term in front of my n term, n minus 1. It's like if I'm talking about the 25th term, n minus 1 would be 24, because 25 minus 1 is 24. So it's always that term directly in front of it. Okay. So a recursive rule. A recursive rule gives us the beginning term. So for a recursive rule, we need to know what term do we start with. It gives us the beginning term. And then a recursive equation. What we mean by recursive is it depends on previous. It depends on previous terms. Hence why we talked about notation for the previous term. That defines the nth term by relating it to one or more previous terms. Okay. So one or more previous terms. So what I'm going to do is I'm going to write a recursive rule for the sequence that we did here. Okay, so what this recursive rule is going to look like is, first of all, it needs to give you the first term or the first couple terms. So I would say, hey, well, f of 1, my first term is 50. Then for any other term, f of n would be equal to the previous term, the term before it, which we would write it this way, f of n minus 1, but then I add 75. Because again, I add 75 each time. So this whole thing here is my recursive rule. I need the first term, and then I need to know how to get to the next term. I take the previous term, and I add 75 to each one. So if I wanted to find the 11th term, f of 11, I would take f of 11 minus 1 and add 75. Or I would take whatever f of 10 is and add 75. So then I have to come up here and know what f of 10 is. My f of 10 was 725. So I would take my 725 and add 75 to it. Okay, 850. Okay. Oh no, 800. Sorry. I read that as a 75. 800. Okay. So again, it just takes, this is again just representing the previous term. Okay. All right, so let's go ahead and let's look at another one. So here we have the first several figures in the pattern are shown. So figure 1 has 1 block, Figure 2 has 3, so forth and so on. So we want to draw figure 4 and 5. So first I'm going to label, okay, what is figure 4 going to look like? We'll draw it there. And what about figure 5? Okay, so first let's go ahead. Let's see if we notice a pattern. This first one has only one block in it. This next one has the one block plus 2 more, so it's got 3. So I take this one and add 2 more to get to that one. What about this one? It takes the previous 3 and adds 2 more, which gives me 5. So we're adding 2 each time. So figure 4 is going to have the 5 blocks. 1, 2, 3, 4, 5, and then add 2 more, 6, 7. So it's going to have 7. 1, 2, 3, 4, 5, 6, 7. Yep. And then figure 5 is going to take those 7 and add 2 more. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So here they say let S of n equal the number of squares in the nth figure. Write the first 5 terms of the sequence defined by S of n. So we already have like the first, we kind of have them written over here, guys. We have 1, 3, 5, and then 7, 9. So the first 5 terms would be, we go 1, 3, 5, 7, and 9. We list the sequence using commas to separate 1, 3, 5, 7, and 9. First term, second term, third term, fourth term, fifth term. Is the sequence defined by S of n, an arithmetic sequence? Yes. It has a common difference. A common difference of 2. Okay. Write a recursive rule for S of n. Use the recursive rule to find S of 6 and S of 7. Okay, so for my recursive rule, so first I have to say my first term, S of 1 equals 1. Now I have to write how to get the next term, S of n equals. I take the previous term, which I'd write it as S of n minus 1. So again, there's my previous term notation, F of n minus 1 from up there. S of n minus 1, and what do? I add 2 each time. Okay. So now it says use the recursive rule to find S of 6. So S of 6 is going to equal S of 5 plus 2. What is S of 5? Fifth term. S of 5 is 9, so I take 9 and add the 2, I get 11. So there's S of 6. Now to find S of 7, I take the 6th term, add a room, and add 2. 6th term is 11, add 2, I get 13. So there I am using that recursive. Okay. So in general, a recursive rule here in general, a recursive rule for an arithmetic sequence with a common difference of d is given by f of 1, you name the value of the first term, then f of n equals the previous term plus d. This would be for values. All this tells me, all this guy right here tells me, is it works for terms 2 on up. Because it won't work for term 1. Term 1's down here. So n has to be greater than or equal to 2. That just means for term 2 on up. Okay. And this common difference also could be negative. If the common difference is negative, then it's going to go, the sequence is going to go down. And your d would just be negative. So it'd be a subtract. Okay. All right. So here we have another task. So the photo shows the cost of admission to an art museum. Let f of n be the total cost in dollars for n visits to the museum during the same month. So first visit is $25 right there. $5 for each additional visit, right? The first 5 terms of the sequence. So it's $25 for the first visit. And now for the second visit, it would be the 25 plus an additional 5. So now I'd have $30 in. And then an additional 5, which would be 35, an additional 5, 40, and then 45. We have the first 1, 2, 3, 4, 5 terms. So there's my first 5 terms. Is it an arithmetic sequence? Yes. Has a common difference of 5. It goes up by 5 each time. If so, what is a common difference and what does it represent in this situation? Yes, it has a common difference of 5. What does it represent in this situation? what? The cost increases by $5 per visit. It's a rate. That common difference is a rate. It's a rate. Or even more specific, a rate of change. Okay. So it's that rate of change. It goes up by $5 each time. What is the recursive rule for the sequence? So they tell us to use f of n. So first, for a recursive rule, I need to state what the first term is. F of 1 is 25. Okay. If f of 1 is 25, then f of n is going to be equal to the previous term, n minus 1, plus that common difference of 5. So f of n minus 1, I take the previous term and add 5. What is the value of f of 8? And what does it represent? Okay, so first I have to find the value of f of 8. So this one right here is f of 1, and this would be f of 2, and then we have 3, 4, 5. So here's f of 5. The farthest we have is f of 5. So I have to keep going to find f of 8. This is where recursive rules aren't helpful. Recursive rules are nice. They're the easiest type to write. But if I want to know what f of 100 is, I have to find all of them from 1 to 99 to be able to find f of 100. So a recursive rule, not helpful in this situation. Now this one's only f of 8, so that's not too bad. So I can keep going. So f of 5, so we know the fifth term. I'm just going to go ahead and kind of create a table. The fifth term is 45. The sixth term then would be 50. The seventh term would be 55. We go up by 5 each time. And so the eighth term would be 60. So f of 8 equals 60. What does it represent? Cost of 8 visits to this museum in a month is $60. That's what it represents. Okay. But again, if I needed to find f of 100, a recursive rule is not helpful. I would have to find all of them from 1 to 99. Okay. So we're going to come up with other rules. There's better rules when it comes to finding that later on. We can actually graph arithmetic sequences. You can graph a sequence on a coordinate plane by plotting the numbers. But since the domain is generally the set of natural numbers or whole numbers, or what we call our counting numbers, the function is discrete, aka no in-betweens. So with the graph, don't connect the dots, because we can't include the numbers in between. So given the table representing, so here we have an arithmetic sequence. We want to write a recursive rule for it. So first, to find that recursive rule, I need to know the first term, which we know that it's 20 right here. And then I need to know that common difference. It looks like it's going down by 4. So my common difference is -4. So my rule, f of n, equals f of n minus 1, the previous term, minus 4. Or plus a -4, however you want to do it. Find the nth term of the sequence. So again, I only have found up to the fifth term. I have to keep going to find the rest of them. So we're kind of out of room over there. So, we need to graph it. It also says write a recursive rule to the sequence and graph it. So it looks like I'm going down. I'm starting at 20. So, but we only do a positive. So I'm going to go ahead and I'm only going to do draw axes 1 and 4. So the first term, so here at 1, we're at 20. Shall we count at 2s? 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Sure, that works. Here's 20. We have to label. We're counting by 2s. So the first term is 20. So there's a dot there. The second term is 16. Here we'll count by 1s on this axis. Make sure you mark it as such. So 2, we go to 16. So 2, 4, 6, 8, 10, 12, 14, 16. The next term, we have 12. Right there. Get rid of this guy. Get rid of those two, because those are just my counting marks. Okay. The 4, we have 8. So here we have 4, 2, 4, 8, 2, 4, 6, 8. 5, we have 4. So now what we could do is, so now we need to find the nth term. the ninth term, I could continue out this table, or I can just go ahead and continue out the graph. I think I'm going to continue out the graph since we're kind of on a roll there. So it looks like it goes, so now that's the fourth term. So the fifth, so this is fifth, 5, 6, 7, 8, 9. We need to go to the ninth term. So we go down 4 each time. So there's 6, 7, 8, 9. So it looks like there, the ninth term, we're right here at, and we're counting by twos, 2, 4, 6, 8, 10, 12, negative 12. So it looks like my ninth term, f of 9, is negative 12. I could, again, continue out this table, 6, 7, 8, 9. And it should confirm that. Here we have 4, 0, negative 4. We're going down by 4 each time, negative 8, negative 12. Yep, we confirm. Oh, I don't know why I have a parenthesis there. All right, so we wrote the recursive rule. That's this guy right here. We graphed it. Again, we don't connect the dots. We just have the points, dot, 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 because it's discrete. And we found the ninth term. We found everything we're looking for. All right, here's our very last one. So here the photo shows a transporter rental charge. I think those are like segways. I don't know why they didn't use the word segway. For guided tours for a group of 25 or less. Make a table and a graph for the arithmetic sequence that models the situation. Then write a recursive rule for the sequence, and then find the cost for 8 people. So there's a way multiple. So it's $40 for the first rental, $20 for each additional rental. So I'm going to go ahead and I'm going to create a table. I like vertical tables just because they take up less room on my paper, I think. So for the first person, it's $40. So for 2 people, it's going to be an additional 20. So that would be 60. For 3 people, it's going to be additional 20, 60, 80. For 4 people, an extra 20. 5 people, an extra 20. So we can see here my common difference is 20. So we made a table and a graph, so we need to graph it. So these numbers are only going to be positive because they're only going up. So I'm going to go ahead and I'm going to stick with quadrant 1. Okay, and we are going up by like 10 or 20 each time. So maybe we count by tens on this axis. This axis will count by ones. Here we'll count by tens. So for the first person, it's $40. So 10, 20, $40. Okay. For 2 people, it's 60. For 3 people, it's 80. For 4 people, it's 100. It goes up $20 each time. So forth and so on. Okay, so this is counting by ones. Again, I have to have my scale. You have to have a scale for your graph to show which one is which. And then this is cost in money. And this is number of people. Label your axes. What are they representing? So we have our table. We have our graph. Then write a recursive rule. So our recursive rule, we need the first term, f of n. Our first term is 40. Oh, typo, that should be f of 1. My first term is 40. F of n equals the previous term, f of n minus 1, plus an additional $20. So f of n minus 1 plus 20. And then use the rule to find the cost for transporter rentals for a group of 8 people. So they want us to use the rule. The last one we found in our table was f of 5 is 120. So f of 6 would be equal to f of 5 plus 20. So that would be 120 plus 20, which is 140. We have to keep going. F of 7 would be f of 6 plus 20. So that would be 160. F of 8 would be f of 7 plus 20, 180. So $180 for 8 people. 5, 6, 7, 8. Again, you have to find all the numbers in between, which makes the recursive rule not as useful as other rules.